Today we're going to take a look at our last section in chapter 5, and it's called Corresponding Parts of Congruent Triangles Are Congruent. We use the abbreviation CPCTC, and a lot of times we just use CPCT. Right? For corresponding parts of congruent triangles, what we're allowed to say is that once we've proved two triangles are equal, then each angle inside in the one triangle has a matching equal part in the second triangle. So the first thing is that we have to prove the two triangles are equal to each other. So prove the two triangles are congruent. Once we've done that, then we can say that each angle and side of the first triangle has a matching pair or matching angle or side in the second triangle. So everybody in the first triangle has someone they're equal to in the second triangle. Again, the first thing we have to always do is prove the two triangles are congruent first. So let's take a look at 3 example proofs, and then you guys are going to practice them on your own. We want to go ahead and always make our statements and reasons table. And in our picture, we can see that we're given that side AB is equal to CB. AB is congruent to CB. The top sides are equal, and then the bottom sides are equal. AD is congruent to DC. And that's given to us in the picture. To prove my two triangles are equal, I want to go ahead and use my reflexive property and say that the middle side, BD, is equal to itself. So now in step 2, we can say that side BD is congruent to itself, BD, and that's the reflexive property. We now have enough information to say my two triangles are equal to each other by side, side, side. So in step number 3, I can go ahead and say that triangle ABD is congruent to triangle CBD, and that's by side, side, side. Once I've proved the two triangles are equal to each other, then every angle and every side in the first triangle has a matching partner in the second triangle. So in step number 4, I can go ahead and state that angle A is in fact equal to angle C, and my reason is this new reason we just learned today. CPCTC. Corresponding parts of congruent triangles are congruent. So each angle inside in the first triangle has a matching partner in the second triangle. Let's take a look now at example number 2. In number 2, we've got this kind of hang glider guy. And again, I'm going to start with my statements and reasons table. And in statement number 1 here, we're given that the outside angle, number 1, so let's mark this guy, this outside angle here, and this outside angle here, number 2, that those two are equal to each other. So angle 1 is congruent to angle 2. Interesting. And then we're told that angle RTQ, and it's kind of hard to see that T in the middle. So RTQ, this guy right here, angle RTQ is equal to angle RTS, this guy here. And so that, of course, is the given. Now, right now, I only have one pair of equal angles that are equal to each other. 1 and 2 are actually outside of the triangle. But I can say that angle 1 and his angle RQT are supplementary. They sit side by side on a straight line. 2 and RST are supplementary. They sit on a straight line. And then I can go ahead and say that RQT and RST are equal to each other. So let's go ahead and start with saying that angle 1 plus angle RQT, they add up to 180. They're a linear pair. And using the same reason, angle 2 plus angle RST add up to 180 because they're also a linear pair. They're supplementary. They add up to 180. So then I can go ahead and set those guys equal to each other. And I can say that angle 1 plus angle RQT is equal to, oops, let me move this over a little bit. Angle 2 plus angle RST. And if they're both equal to 180, they're equal to each other. So I can either use the transitive property or substitution. Either way, I'm going to use substitution because I'm going to plug 2 plus RST in for 180. And now I can subtract off my angle 1 and 2 that are equal to each other in the given to get a second pair of equal angles. So now in step 4, I can say that angle RTQ and angle RST are equal to each other. By the subtraction property. I subtracted off 1 and 2 because in the given they told me 1 and 2 were equal to each other. I now have a second pair of angles that are equal to each other. And then I can see that these two triangles share that middle side, R at T. So side RT is equal to itself, RT. And that's reflexive. And so I can now go ahead and say the two triangles are equal to each other by angle, angle, side. Angle, angle, side. So triangle RTQ is congruent to triangle RST by angle, angle, side. And we know that once two triangles are equal to each other, then last but not least, I can go ahead and say that all the parts are equal to each other. So QT has to be equal to ST. And that's that new rule that we use after triangles are equal to each other, CPCTC. Corresponding parts of congruent triangles are congruent. So that one was a little bit longer, but that's okay. Let's take a look at one more, and he's a little bit shorter. So we're given that angle 1 and 2 are equal to each other, and that 3 and 4 are equal to each other, and we want to prove that AD and AB are equal to each other. So again, let's start off with our statements and reasons table. And in the given, we've got angle 1 being congruent to angle 2, and angle 3 being congruent to angle 4. Well, we have two sets of angles, and if I take a look at the two big triangles, they share this middle side AC. So I'm going to go ahead and say that AC is congruent to itself AC. and that's the reflexive property. And now I can prove the two big triangles are equal to each other. So I can prove that this top triangle, ADC, is equal to ABC. So I don't even need anything about this middle line in here, just kind of a little distractor. So my top big triangle, ADC, is equal to my bottom triangle, ABC, and that would be angle side angle, which means that now in step number 4, I can go ahead and say that yes, indeed, side AD is equal to side AB by our new rule, corresponding parts of congruent triangles are congruent. CP, CTC.